If you're a fresher and you have just learned about the web development or mobile development, you might be thinking that you know about the front end, you know about the back end, you have worked with the databases, and that's it. This is all about the full stack development. But this is not. When we are talking about the softwares which will be used by the millions of the user, there should be discussion on the system design. Hi, my name is Aryan Diri, and I have been developing websites for more than 3 years. And currently, I'm working on the system designs of the software. So, and also in this video, I'm gonna show you the system designs of the softwares. So, let me share my screen first. All right. So, what we are gonna do today is we are gonna design a system for the LeetCode. So what is LeetCode? LeetCode is basically a uh, code execution platform where the users can practice the executions. So let me give a high level idea that what LeetCode does. Let's say we have a client here and we have a server here, backend. You can call it backend also. When the client writes the code solution on the front end and hits that submission button on the client side, the whole code sent to the server, and then this is the responsibility of the server to execute that code, to run that code on the test cases, and then give back the result to the client. So give result back to the client that the submission is rejected or accepted. So this is the basic high level overview that what the LeetCode does. So before designing the system for the LeetCode, we should ask some questions that what are the requirements of the software, uh, or we can say the features of the sort, what the features should be in this platform. So what features we can keep in this website, like let's assume we can have a auth system, we can have a feature of problem, uh, we have submission. In this submission, the problem, the user's code, the language in which the user have coded, and test cases. All right. What else we can have is leaderboard. So all this functionality we have to implement on our LeetCode. So let's start with the very beginning. Let's assume we have a client. Okay, the client means this can be anything. Um, it can be a web browser, the client can be a mobile app, the client can be postman, the client can be terminal, client can be anything. So I'm not writing specifically browser or front end, the client can be anything. And we have a server, I will call it a primary server, or you can call it backend, and we have our database. When the client writes the code solution on the front end side or the client side, and when the client hits that submission button, the whole code with problem statement, with test cases, with users code and the language creates a submission, and that submission sent to the primary server, and then the primary server stores that submission to the database, and primary server gives that submission to a service which is also which can be called as code execution engine. All right. So when the client submits a solution of the problem, the primary server stores that submission to the database, and a primary server give that submission to the code execution engine. And this is the responsibility of the code execution engine to execute that uh, user's code on some test cases and give result back to the primary server, and then the primary server will return the result to the client. So in very high level, the software will work like this, but you can see that there are some flaws on this design, like there is um, tight coupling over here. uh, if we are talking about the code execution engine, uh, this is not possible to get a result immediately here, because the code execution engine have to do so much of work. We don't know about the user's code, that how much time it will take to execute. So we cannot expect the immediate result here. So if the client sends the submission here, the primary server will put it in the background, and the primary server will store that submission on the database, and then the primary server will return the uh, ID of the submission. And the primary server will say to the client that, hey server, hey client, I am giving you the ID. I can't give you the immediately, I can't give you the result immediately. I am giving you the submission ID, and you can ask me after some time about the submission ID. Basically the server wants to say that, hey client, you can poll me after some time. And whenever the execution engine will return me the uh, result, I will give you that result. So this is a very high level design of code execution engine, or we can say the LeetCode platform. But we have to remove this tight coupling. So what we can do is we can uh, put a queue here, and this is the queue. And whenever the client submits the submission to the primary server, the primary server will store that submission to the database, and the primary server will return the submission ID. And the client can poll to the primary server for the result of the solution, and the primary server will put that submission to the queue. And then we have something known as worker nodes. And this is a responsibility of the worker node to pull that submissions from the queue and give that submission to the code execution engine. And then the code execution engine will start executing that executing that user's code on the test cases, and give result back to the primary server. Here we have no need to implement any type of queue, because it can be done synchronously. So in this way, we remove the tight coupling from here. And then what what's happening here is the client submits the submission here, and the primary server returns the ID of the submission, and clients continuously starts polling to the server to for the result of the submission. The primary server sends the submission to the queue, and the worker node pulls the submissions from the queue and give it to the code execution engine, and code execution engine executes that code and give result back to the primary server. And when the primary server had the result, it give the result back to the client. So this is the I can say that this is a very good system design, because we have remove the tight coupling from here, but still there are some flaws that the client is directly talking with the primary server. So we can scale up, we can vertically scale this primary server, but if we have to scale horizontally, then we have to introduce some more new things. So let me first copy this whole thing here. All right. So let me remove this arrows from here. All right. So we have a client here, and now we can have multiple. Let me remove this also. So okay, so we have a client, and we can have the multiple primary servers here. Uh, let's say we have 4 primary servers, and this all servers are part of a cluster, and all these servers are talking with the database. And the we have something known as load balancer. All right, so this is load balancer. So the client talks with the load balancer, and this is the responsibility of the load balancer to distribute the load across the servers. And all these servers are connected with the this queue. Let me name it uh, submission queue. And all these primary servers are talking with the submission queue. uh, all right. So all these primary servers are talking with the submission queue, and whenever they get a submission, they put that submission to the submission queue, and then the worker nodes pull all that submissions from the submission queue and give it to the code execution engine. And whenever the code execution engine is uh, and whenever the code execution engine have completed the execution of the code, it give back to the it give result back to the primary server, and then the primary server give result back to the clients. Here we have no need to worry about the state, because this all servers are stateless. So the code execution engine can give the response to any server, and this will give that result back to the client. So this is a whole idea of system design of um, code execution platform. Let me show you what this execution engine does. So in this code execution engine, what there is a concept of something known as containers. So let's say we are working with um, 3 programming languages, like we are supporting Java, we are supporting JavaScript, we are supporting Python, and we are supporting C++ also. So the code execution in so when the worker sends the submission to the code execution engine, this is the responsibility to spin up a container of a runtime here to execute that user's code. So we have something known as AWS fargate. and this AWS fargate is responsible to spin up a container of language runtime. And when the worker node give submission to the code execution engine, the um, containers start that starts executing that code. So there is separation between all these containers. There is no networking between all these containers, and they are totally isolated with the um, external outside environment. So if the code is um, if the code is not secure, then it will not impact, it will not affect the outside system. It will just crash the container, and the AWS Fargate will again spin up that container. So this is all about the system design of the uh, LeetCode like platform. So I'm not telling you that after watching this video we'll be able to compete the LeetCode, but you will be able to understand that how the system works, how this um, queue system, how this asynchronous system works, and we have to use this queue here, because I have already told you that code execution can never give the result immediately. So if the code execution is failed to give result back to the premise server, the whole system goes down. The whole system will go down. So um, as let me know you one more thing, that this is not necessary that we have just we can have only one worker node. We can have multiple worker nodes also, and all this worker node will pull the submissions from the queue, and all these worker nodes will give that submission to the code execution engine, and the code execution will start executing that code and give result back to the primary server and the clients. And I have told you before, I have already told you before that the primary server stores that submission on the database. So whenever the code execution engine gives the um, a result back to the primary server stores that result to the client, result to the databases, and then the primary server give back the result to the client. So this is all about the system design of a platform like LeetCode. So thank you everyone.